Hello and welcome. In this video, we will be talking about voltage and current source. What is real voltage source? What is ideal voltage source? And in similar way, what is a real and ideal current source? We'll be discussing about that in detail in this video. But before we start with the explanation, if you have not subscribed to channel, make sure you do subscribe to the channel because the next video of this series will be publishing after we reach 100,000 subscriber. We are near to that. Soon we will be reaching that milestone. So if you haven't yet subscribed, make sure you subscribe to the channel so that you get next video of the fundamental series, right? So let's start with the voltage and current source. Let's first understand what is voltage and current source. So voltage source is of course a source of energy which establishes a potential difference across its terminal. Now we have already understood in the initial videos of this series what is potential difference. I will not explain that again. If you want to know what is potential difference, what is voltage, do check that out. Do check out that video. You will get link for that video down in the description. So anything that can establish a potential difference across its terminal, it can be called as voltage source. So the example includes a battery. Then you can also call DC generator as voltage source. Then alternator can be also called as voltage source. What they do, they establish a potential difference across its terminal, and as a result electron starts moving, right? So battery, DC generator and alternator can be called as voltage source. So in similar way, a current source is a source of energy which provides the current. Now current source are only mathematical representation. You will not find any practical source that can be called as current source. It is just a mathematical representation. And anything that provides the current, it can be called as current source. But as I said, it's only a mathematical representation. There is no pure current source available practically, right? And one more important point, the elements that provides energy to the circuits are called as active element in the circuit. So voltage source or current source, they provide energy to the circuit and hence they are called as active element. Clear? In similar way, the components who consumes energy is called as passive elements. So you can take for example resistor, they consumes energy and that component we can call it as passive element, right? So active element and passive element, remember that is important. Now let's start with the ideal voltage source. Now to understand what is ideal voltage source, let's do one simulation. So here we have a simple circuit. In this circuit we have a 10 volt voltage source and a load as resistor as a load which is 10 ohms. We have connected a voltmeter across this voltage source to measure the terminal voltage, and we have also connected a ammeter in series to check the current flowing in the circuit. Now let me start the simulation. So as you can see, the voltage source is rated for 10 volts and across its terminal we are also getting 10 volts. And the current flowing in the circuit currently is 1 ampere when the load is 10 ohms. Now let's do one thing. Let me increase the load in the circuit. Let's see what happens. So this is 10 ohms currently. Let me make it as 20 ohms. Now let's see what happens. Now we have increased the resistance. You can see we are still getting 10 volts at the terminal of this voltage source. Even though we have increased the load, the terminal voltage is remaining the same. However, the current has dropped to 500 milliampere. Now let's do one more thing. Let me further increase this load. This time we will make it as 50 ohms. Now let's see what happens. So as you can see, still the voltage at the terminal of this voltage source is 10 volt. Now we have increased the load to 50 ohms, but the terminal voltage is still the same, that is 10 ohm. But again, the current flowing in the circuit has dropped to 200 milliampere, right? So the point is, In this circuit, we have increased the load, but still the terminal voltage is not changing. It is still remaining the 10 volts. We tried it with 10 ohm load, then 20 and then 50, but the terminal voltage is still the same, that is 10 volts. So this type of load or this type of source is called as ideal voltage source, right? So let's see the definition of ideal voltage source. The ideal voltage source is one that maintains a constant terminal voltage no matter how much current is drawn from it. Now we have seen we connected 10 ohm resistor first, then 20 and then 50, but still the voltage across the terminal of that voltage source was constant. So of course that was the ideal voltage source. Now let's understand what was happening in the ideal voltage source. Now in the first step, as you can see, the load was 10 ohms, right? And the second thing in the second step, what we did, we increased the load to 20 ohms, but still the voltage was constant. Now how the voltage is remaining constant? The answer is very simple, Ohm's law. Now what Ohm's law tells us that V is equals to I into R, that is current multiplied by the resistance. Now this indicates that the voltage depends upon two parameters. One, the current, and second, the resistance. If you keep these two things constant, you will have a constant voltage, right? Clear? But in this case, what happened is we changed the resistance from 10 to 20. So R changed. So to keep the voltage constant, what needs to be adjusted? Yes, of course, the current. We need to change the current in order to keep the voltage constant. And that's what happened in the ideal voltage source. You can see initially the current was 1 ampere, but when we increased the load to 20 ohms, the current dropped to 500 milliampere. The current became 50%, right? And if you multiply 50 milliampere into 20 volts, you will get 10 volt as the voltage. And that is our terminal voltage. So understood how voltage is kept constant there by adjusting the current. And in similar way, in this third step, when we increase the load to 50 ohms, the resistance changed again. And again, to keep the voltage constant, we need to adjust the current. And that's what happened. You see, the current is dropped to 200 milliampere, right? And that's how the voltage is remaining constant. Clear? Understood what is ideal voltage source? The ideal voltage source can be represented by using this symbol here. Now that was about the ideal voltage source. Now, as the name suggests, it's the ideal voltage source. So definitely it do not exist practically. In practical life, you will not find a perfect ideal voltage source. There can be some voltage source which are near to ideal voltage source, but they are not perfect. There will be some imperfect thing in that. And what is that imperfect thing? It is the internal resistance of voltage source, right? The ideal voltage source do not have any internal resistance, and that's why they can keep the terminal voltage constant. But the practical voltage source do have internal resistance. So let's take example of DC generator. Now DC generator will have internal windings, right? And that internal winding will definitely have some resistance. You cannot avoid that resistance. Of course, you can make it less, but there will be some internal resistance present in that winding. And that is the imperfect element in the ideal voltage source, right? Now let's explore the real voltage source. So the real voltage source has internal resistance, which is generally low, which causes drop in terminal voltage when the load current increases. So for sure, this, as I said, a real voltage source will have some internal resistance, which will cause the terminal voltage to drop as and when the load increases. Now let me show you that one in the simulation. So as you can see in the circuit here, we have represented a resistance in series with the voltage source. Now that this indicates the real voltage source. Now the value of this resistance is generally very low. For understanding purpose, I have kept it 500 milli ohms. Let's see what happens now. Now let me make the load as 10 ohms. So you see the voltage, the terminal voltage is dropped. It's not 10 volts. The voltage source is rated for 10 volts, but it is not giving us 10 volts. It is 9.52 volts. Definitely the terminal voltage has dropped. And because of which reason? Of course, the internal resistance. There is some voltage drop happening across this internal resistance, and which is causing the terminal voltage to drop. Now this is the situation when the load is 10 ohm. Let me increase the load and see what happens. Let me make it 20 ohms here. So as you can see, the terminal voltage is changed again. It is now 9.76 ampere. The current is 488 milliampere. When we made the load as 20 ohms, it is changed. Now one more time change the load here. Let's make it 50 ohms. Let's see what happens. 9.9 volts. So again the terminal voltage has changed. So as we are increasing the resistance, the terminal voltage is also increasing, right? Why? Because the current is decreasing, and that is causing the voltage drop in this internal resistance less, and as a result we are getting the terminal voltage higher. So that is nothing but the practical voltage source. So you can also see in the graph, when the load current increases, the terminal voltage decreases. You see here, the load current increased, but the terminal voltage also dropped. So that is the real voltage source. And the real voltage source is represented by simply the ideal voltage source, and in series with that you can show a resistance. That is the representation for real voltage source. So the bottom line is, what causes the voltage drop? The internal resistance. As the current increases, voltage drop in the internal resistance increases, which decreases the terminal voltage across the voltage source. And this is the practical situation. You will see batteries. Now batteries, I will say they are near to the constant voltage source, but still they are not the perfect voltage source, perfect ideal voltage source. There will be some internal resistance which will cause some voltage drop, right? Now let's quickly compare the ideal voltage source and a real voltage source. So the ideal voltage source has no internal resistance, right? Whereas the real voltage source has some internal resistance. Generally it is low. Then the terminal voltage remains constant for any load current in case of ideal voltage source, that we have also seen in the simulation. Whereas in case of a real voltage source, the terminal voltage changes with change in load current, right? That is the basic comparison between ideal and real voltage source. Now let's talk about the ideal current source. As I said initially, the current source are only the mathematical representation. It is difficult to imagine a current source practically. So we'll just understand what is ideal current source mathematically and what is practical current source. Let's go to the simulation. So here is the simple circuit that we have. We have taken a current source of 5 ampere. We have connected a voltmeter to measure the voltage across this current source, ammeter to measure the current flowing in the circuit, and we have load as a 10 ohm resistor. Let's start the simulation now. Now you can see we have started the simulation. Current flowing through the circuit is 5 ampere and the current source is also rated for 5 ampere. Currently the voltage across this current source is 50 volts. So now let me increase the load here. Let's make it 20 ohms to see what happens. So as you can see, still the current flowing in the circuit is 5 ampere, but the voltage has changed. It is now 100 volts. Again, let's increase the load to 50 ohms. See what happens. You see, Still the current flowing in the circuit is 5 ampere, but the voltage has increased to 250 volts. So such type of sources wherein the current is always same no matter what is the load connected in the system is called as the ideal current source, right? Let's see the definition of this properly. The ideal current source is the one that supplies the same current to any load that is connected across its terminal. We saw that in the simulation. We connected 10 ohm, 20 ohm and then 50 ohm, but still the current supplied by the current source was 5 ampere. So definitely that was the ideal current source. So let's see what was happening in the ideal current source, how the current was remaining constant. So in the first step, the load on the circuit was only 10 ohms, right? And the current flowing was 5 ampere. The voltage was 50 volts. In the second step, what we did is we increased the load, we doubled the load and we made it as 20 ohms. Again, Ohm's law comes into picture. So if resistance is changing, to keep the current constant, what is the other parameter that needs to be changed? Of course, that is voltage. So you see the voltage in second step has changed. It has now doubled and it has become 100 volt. Current still remains the same because the voltage across it is changing. And in similar way, in this third step, when we increased the load to 50 ohms, the voltage also increased to 250 volts. And because of that, the current remained the constant, that is 5 ampere. So that is how the ideal current source keeps the current constant no matter what is the load connected across its terminal. You can represent the ideal current source by this symbol, right? But again, as the name suggests, it's ideal and therefore it do not exist practically, right? And because of one imperfect element, and that imperfect element is of again the internal resistance of the current source. Now let's look at the practical or real current source. The real current source has high but finite internal resistance, and hence the value of current will change as the load changes. Now initially when we saw about the ideal current source, it had infinite resistance, but in case of a real current source, it has high but finite resistance. It is not infinite, and hence the value of current will change as the load changes, right? Now let me show you in the simulation how the value changes because of the change in load. So look at the circuit. Now it is the same circuit. The only thing is the current source in this circuit is real. And how you can guess that? Because we have connected an internal resistance in parallel with the current source. Now this internal resistance is connected in parallel in case of current source. Now let's see, let me make this a load as 10 ohms. So you can see the current source is meant for 5 ampere, but the current flowing in the system is 4.95 ampere. There is some current also flowing from internal resistance. So the current is not now 5 ampere, it is 4.95 ampere. Again, let me make it as 50 ohms. Let's see what happens. So now we have made the load as 50 ampere and you can see the current has further dropped and it is now 4.76 ampere. So definitely the internal resistance is doing the damage here. The source is rated for 5 ampere, but current flowing in the system is only 4.76 ampere. So that is the practical or the real current source. Also, if you draw the graph between the terminal voltage and current, you will see as the terminal voltage increases, the load current decreases. And why this happens? Because of internal resistance of the current source. You can represent internal current source with an ideal current source in parallel to that a resistor is connected. So that is how you can represent the real current source. Now let's quickly compare the ideal and real current source. So the ideal current source has infinite internal resistance, whereas the real current source has high but finite internal resistance. Load current remains constant for any type of load in case of ideal current source, whereas in case of real current source, the load current changes with change in load. These both conditions we have already seen in the simulation. So I hope the concept of voltage and current source is clear to you. And as I said initially, if you want to have a next video of this series, make sure you click on the subscribe button, because we will be publishing the next video only after we hit 100,000 subscribers, right? So that's all for this video, guys. I'll see you in my next one. But till then, keep watching, keep learning.